Okay, I think I'll make a start. Can everyone hear me at the back there? Okay, I'll try and be loud enough for you, but not disturb Elaine's group there. Hi, my name is Colin Griffiths. I'm an operations superintendent with Talisman Sinopec, but I've been seconded to the EBS work group by Step Change in Safety. I have a team working for me, with me, representatives from the oil and gas industry, specialists, helicopter operators, Workforce 971 reps, and we have support from Step Change itself by Emily Taylor. Sue Coleshaw is actually Dr. Sue Coleshaw. She is the lady that largely wrote the standard civil aviation publication CAP 1034, which describes the requirements for a Category A breathing system. Greg Alanach from Savitec, who are the OEM, who are responsible for the display and the equipment today. Davey Hunter is an aviation specialist from Shell. And the helicopter operator is actually, it says operator, that can be one of any three companies, Bond, Bristow or CHC, actually sit on the group. Our terms of reference are to identify and select potential solutions that meet this standard. And we work with the PTO, CAA, EASA, and others. And before I go any further, I'll just give you a brief background about myself. As I've said, my day job is to work with one of the oil and gas majors in operations. But I've been in oil and gas for 20 years. But prior to that, I was professional aircrew with the Royal Air Force. I flew on Nimrods for a number of years based at RAF Kinloss. So I have an aviation background. Right, see if I can get this thing to work. I'll jump back to this slide. There's a few misnomers. What is a Category A EBS? Category A EBS doesn't currently exist. So the standard that will describe a Category A system exists. There are a variety of emergency breathing systems on the market that may or may not meet that requirement. So what we did as a group was, instead of going back to first principles, we had a look on the market to see what existed and what was likely to meet the standard. And we compiled a decision matrix. That decision matrix looked at compressed air systems and actually did look at the current rebreather system to see if we could modify something that you were already familiar with. It became obvious very quickly that given the requirements of a Category A system, it was unlikely to meet that requirement. And as you've heard earlier on, the Category A system has a requirement that it can be deployed single-handedly, in fact, with either hand in air or underwater within 12 seconds. Okay? And as it says there, the current doesn't meet this standard and is unlikely, even with modification, to meet it, mainly due to the time of deployment. I want to jump straight to the timeline to give you more time for questions. The place where we're at now, April, is the development stage. Development and testing is normally an iterative process. You come up with a design, you offer it for testing, you make some modifications, you go back into the development phase, and then you bring it back into testing. The product that we looked at is fairly mature. The product that came out top of our candidate selection matrix is called PSTAS. And the military use it for their passengers. It's deployed in a very different way. It's worn around the waist in a pouch. In that format, it's very unlikely to meet the Category A standard. So what the very clever people at Savitec did was actually to incorporate a compressed air breathing system, a bottle and a regulator, into a composite solution with a new life jacket. Okay? And it's this system that we're putting through certification and testing with the CAA. The testing phase has some way to go. We have done two sets of tests at the moment. Firstly, when you introduce a new system, you have to test backwards compatibility with existing safety equipment. So the new jacket had to be tested with the existing suit, etc. That happened 2 weeks ago, and that's under the bailiwick of EASA. They looked at that. They haven't come back to us with any objections, and the indications are that that went very well. The next stage we conducted last week. We went to Fleetwood, which is a certified test centre, and we did our in-water testing with our subjects against the requirements of this CAP 1034. The testing went very well, I'm very pleased to tell you, and we tested in various phases. We looked at the candidates, we fitted them with equipment, we tested their deployment in air, we looked at how they interacted with it. And one by one, they went into the pool, they did a submersion test. Again, some of you might be familiar with the rebreather, hand over hand on a rail underwater. Later on that morning, we gradually progressed to what is called a sweat chair, which is a floating chair, which you sit in with a helicopter seat, you're inverted. And we did a static breathing test with no exertion for a minute. And we looked at how they cope with it, how they cope with breathing inverted, and are there any interactions with the system. Once we did that, we spent the afternoon then in the Hewitt doing the normal range of testing that you would expect. Partial immersion into water and escape, full immersion, vertical immersion into water and escape, and immersion and capsize and escape. And again, the testing went very well. We found that as the day went on, all our subjects were complete novices. They weren't handpicked. These are volunteers. These are the people that volunteer for scientific tests, and they come to us and they get paid, and you know, they give us their honest opinion of these things. We found that the confidence greatly increased from the minute they had it. So there's a big learning there for us, that actually the more training you do, clearly the more confidence people had in the equipment. We didn't find any difficulty at all with the breathing system so far. So that's the testing. We have two further elements to do. There's a fairly scientific laboratory test to do with a company called Kinetic, which will test the work of breathing on the device. Again, that's a sort of laboratory-based test that's fairly scientific, and that'll come up with a set of standard measurements, how this thing reacts. The last one, which is very important, which is at Portsmouth University, and that's the cold water immersion trial. So again, with some unlucky subjects, we'll have to go into water about 12 degrees C, and believe me, it sounds warm, that is very, very cold. That invokes the cold response shock, nerve pain, muscle stiffness, difficulty in controlling your respiratory rate, and we will be testing this equipment in that environment. Can I just pause there and just see if there are any questions at this stage? Because I'm guessing I've already told you a fair bit.
You were talking about the guinea pigs who had to try them out. None of these people previously worked in the oil industry.
So the question was, sorry, you finished? The question was about the trial subjects and had they had any prior exposure to this equipment, or were they from our industry? The answer is no. They're from a variety of industries, and some of them were students, some of them not in the industry. They hadn't been shown this equipment before very specifically and had to go through a normal dry brief just to understand how to deploy it, but they were definitely not given any briefing, and that was under the scrutiny of the CAA.
Is there a bag on this one where you can expel your own air into it, like on the old one?
No, and actually, if you don't mind, please remind me, and I'll come back to the technicalities of the equipment. What I'll do is I'll allude to some of this. I'll run through the timeline, and then at the end we'll start talking. In fact, I will probably defer to the technical experts on my left-hand side, and they can give you some of the detail about the equipment.
Just a question, another question, and it's just on that pool trial. I'm just looking at the setup there with the bottle, thinking of you strapped into your seat, potential for a snagging point with your seat belt coming over your shoulder onto the top of that bottle. Was there anything like that come out of the trial?
So the question for everyone else in the room was about the snagging hazard, because it is a bulky unit, that's undeniable. And actually that's exactly what the trial is designed to do. So egress through the window, and snags with the seat. So we have a dry cabin mock-up as well, and we didn't find any issue with snagging with the seat belts. The seat belts fit snugly behind the bottle here. Okay, so you can still deploy the unit if you're strapped into your seat. In fact, that's what they do. That's what the device called the sweat chair does. Okay, it's a helicopter seat that you're strapped into in a sort of a roll cage, and you're inverted. Okay, I'll move on a little bit, and we'll take some more questions at the end. So that's the testing and development phase, and as I said, we're some way through that at the moment with very encouraging results. Of course, we can't predict where we're going to be, but we think that with a fair wind, we're very likely to be finishing up our critical testing, beginning to the end of May down at Portsmouth with the cold water testing. Then we have some time to write up the test results. These are scientific tests. The test results will be written up and analysed by the Civil Aviation Authority and ourselves. It occurred to us that there's an opportunity here to do something very special. I have to tell you that our group are not constrained financially, and we weren't given any time constraints. Okay, so whereas the imperative might seem to be the 1st of June, and we are working extremely hard and are very focused to bring any equipment that we do select and certify into service as soon as we can, we are not forcing a deadline. We do not have a drop-dead date to make. Similarly, with the financial side of things, is that our brief tells us that we have to give the best equipment that's available into service for our people offshore. And that's manifest in the procurement side of things. If you look at the procurement line, actually the procurement line extends back and actually overlaps the testing and development phase, and that's not usual. Normally you would expect, for good sound commercial reasons, that you would do some product development, you would offer it for testing, maybe modify it, then come back into testing, and once it's fully landed, then you would go into commercial production. That would extend the timeline. What we've done as an industry is go back to the equipment provider and said, we have enough confidence in our robust selection procedure and having an opportunity to see the kit in action that we think now, on a high-risk basis, commercial high-risk basis, we can start placing orders for the long lead items. And that's what we've done. And as an industry, we've gone back to the equipment manufacturer and we've underwritten them financially to allow them to do this on our behalf, just in case we get and we don't meet certification or we decide that actually this isn't the system that we want. But we've done it to make sure that this will align with the most expedient availability of the system. So that's why the procurement line starts almost really before the end of final testing. The long lead item was the compressed air cylinders. The manufacturer has told us that to meet our demand, and our demand is currently 2,800 units, which is based on the current exposure of the current rebreather system. They told us that they can batch deliver these in batches of 700, so you've got 700, 700, 700. So by mid to end of July, we could have all these bottles in hand. But that's just the long lead items, that's just the bottles. Okay? I've kind of jumped over this because we come to certification approvals, which I kind of described as hand in hand with testing. But as you can see, there's a lag there because we have to write up the test results, they have to review them and come back to us with comments. The next part is manufacturing and assembly. And you might think, well, manufacturing, you've already placed the orders. No, the orders were only for the bottles. You have the first and second stage, the demand valves. You also have a production line that had to be set up to manufacture the new jackets. Because what we're producing is not just a bottle, we're producing an integrated solution for the industry. It's all about the jacket. This is a new jacket. This is all about the bottle and how we mount it and how it's deployed. Okay? So there will be an assembly and there will be further manufacturing and testing to produce an integrated unit. Excuse me while I just take a sip of water. Any questions at this stage? Okay. You'll notice that after manufacturing and assembly we have a line which describes training and medical. And I can imagine that that's quite an emotive issue, that there are lots of questions already we've received about that. Can I give you some reassurance about this? Our group has sufficient experience and qualifications to make some fairly reasoned judgments around the medical and training requirements. But that's not the whole story. There are absolute experts in these fields that we have gone out to, we've reached out to, and we're seeking medical and training opinion. So we are conducting a full training needs analysis to understand what it is we need to do to bring in this new equipment. And we're also doing the same with the medical requirement. So let me deal with the training element first. if you think about it logically, this is not just one big burden of training coming at us. We're not proposing that the 30 or 50,000 people currently on the books in the offshore industry have to go through the helicopter underwater escape trainer. What we're saying is that it's quite apparent that there are two elements to this. We need, as a responsible industry, to understand, to roll out a new piece of equipment, what it is we have to do to train our people to fly with this, to safely and effectively deploy it in an emergency. That's one thing. Again, any responsible organisation, and if you talk to the likes of the training providers and you talk to a PITO, the reason we do the number of activities we do in the Hewitt and we do the capsize and the roll is because that level of increased fidelity gives increased confidence and increased training capability. So we're also saying is we need to examine that element. What do we need to do with this equipment in those type of scenarios? What risk does that present to our workforce, and what benefit does that present to our workforce? They are two distinct activities because it is entirely reasonable, and in fact every person working and travelling offshore should expect to spend their entire working career, whether that's 30 or 40 years, and never end up in the water. Let me stress that, and it was a point that was well made earlier on, is that we're focusing on a very, very narrow aspect of helicopter safety. Your expectation should be, and as an industry, we are doing everything we can to make sure that traveling to and from your place of work is as safe as it can be. Okay, so the chances that A, you will ever end up in a helicopter incident, that it will be a no-notice, sudden impact, survivable incident where you need this equipment are extremely small. But if you are in that situation, this is what you need. This is an on-demand system that requires no preparation and very minimal training. It is primed ready for use. If you need it, you take it out of the holder, you put it, squeeze the nose clips, you put it in your mouth, and you breathe. So there are some safety considerations about breathing compressed air underwater, not holding your breath, and so on. So I've kind of oversimplified it to make a point. So the training requirement for that will look at what video presentations, what training in air, and what sort of wet training, if we go into that arena, you need to cover the rare event that you will ever need to use this. The other end of the spectrum says we also need to look at, do we use this in the Hewitt? How many times do we use in this Hewitt? Actually, if you turn it on its head, if this gives our workforce more confidence and more time, can we do more with this in the Hewitt? Is that a good place to be? Is that desirable? Will that give people more confidence? But they're different, and we're asking our specialists to come back to us and define that and understand if that premise is correct. Okay? And that goes hand in hand with the medical side of things. Everyone who works offshore currently has to have a medical. We've asked the doctors who are engaged in oil and gas, the oil and gas industry, to look at the offshore medical and ask themselves, is there anything else you would recommend for a travelling workforce carrying compressed air? Do we need to do anything more in the medical? I don't know the answer to that. I have no idea. It's likely to be no, because the offshore medical is fairly comprehensive as it stands, but I don't know the answer to that. So that's what you would need to do to carry this equipment, like you would need to do a certain set of training to fly with it. The other end of the spectrum says, if we have a workforce which is circa 30 to 50,000 people, and we put them in the Hewitt every 4 years as it currently stands, possibly that frequency will change with the fidelity and frequency group, working group. That's a lot of people exposed to in-water training breathing compressed air. And there are some risks. There are some risks, it's undeniable. Like there are, I don't know if many of you know, that last year alone, there were 9 shoulder dislocations and normally fit people in the Hewitt getting in at life rafts and getting out of the helicopter, because it happens because you're dealing with large numbers of people. I don't think there's inherently anything scary about using compressed air, especially with the mitigations that we have. But again, we have to understand what the risks are, and then we have to make sure we have the correct mitigations in the training environment to deal with that. So then the medical people also come into play there, and they say, well, you may have an offshore medical. We may have determined that there are no special requirements, but on the day, you will require on-the-day screening to make sure you don't have a bronchial infection, sinusitis, something which would cause you some discomfort or difficulty. leading this. So those two questions are out there to be asked. We've gone to specialist groups to come back to us and define what they are. So have I got any questions on that so far? Okay, no? Oh, sorry, we do. I'm sorry, I'm
You've got the Survival 1 suit, which is the new suit. Is there any compatibility issues with the older suits that are still in service at the moment?
It's a very good question. So the question is, and actually really I should, I know the answer, I think I know the answer, but I should defer. The question was about compatibility with the suit. This is the 1000 series suit, if I'm correct, and there are questions about compatibility. Part one of the testing was compatibility with existing safety equipment. That was the first set of tests that was carried out that was the EASA requirement. And can I defer to the left-hand side of the room and invite someone from Survitec to explain what models of suits were tested?
There's 3 different suits in use in the North Sea. All 3 will be compatible. Sorry. There's 3 different systems or suits in use in the North Sea, and all 3 will be compatible with that life jacket. We have to satisfy. That's a legal requirement, whereas EBS is actually, it's not mandated by EASA, it's purely UK convention. So yes, all compatible testing.
Thanks, Greg. Okay, so the next line item on the project timeline is the deployment training, and this is what I alluded to earlier on, is that the training requirement for deployment and the future higher fidelity training are different, and depending, and this is quite a big line, and there's quite a latitude in answers there, because again, I say we really don't know this, we haven't landed this. It is reasonable for us to expect we have an understanding about September, but actually that date could move to the left. It depends how quickly the specialists come back to us. It could slip if there's some onerous requirement. That's a project risk. But we are being as open as we can with these dates. We're sharing with you some very sensitive things. Sensitive in as much as some of these dates look very, very early. But it is possible. It is entirely possible with a measured and focused response to do what we're saying we can do. It is also, there are things entirely out with our control, the manufacturing and production line issues, certification hiccups, whatever, onerous requirements medically or training we're not expecting, but these things can happen and these lines could all be pushed to the right. However, having said that, when we come down to the deployment model, we have 2 models, and the deployment model says, maybe a little bit difficult to read it off the screen to understand it, but what we're saying is, because we've gone early and we've decided to start procuring the long lead items before we've closed out the testing and anything else, there is a likelihood that if everything falls into line, we will have a batch delivery system. So the bottles will arrive, the manufacturing, the jackets assembly and will take place, and then we would probably have the first of the 700 units as a complete safety system by beginning of August. And it may be desirable as an industry. This is not a decision that our group will take. Our group is designed to provide the best equipment on the market and bring it to have the equipment in hand as soon as possible. But there is a discussion that needs to take place with the boards and the leadership teams of the oil and gas industry, which says who gets what first. If you have 700 units in hand, do we decide to distribute these on a batch basis if we understand the training and medical requirements? Can we do that? Is it desirable to do that? Is it within our gift to try and understand whether we are there to protect the UK energy supply, and therefore we give these units to the oil and gas suppliers that actually provide UK with its largest energy? Do we protect the exchequer, and do we give these units to those oil companies that provide the best revenue to UK PLC? Do we try and be sympathetic to individual organisations who are greatly impacted by this? Or is there some geographic or other reason where we would make this decision? Not myself or my group, but as an industry, we could do this. If there is agreement and if things fall as we think, we have a very go early date of August for potential for some areas seeing this equipment. The date that we're all looking at the moment, we have a reasonable expectation that we would have all the equipment in hand and most of this closed out by the 1st of October. We think that is quite a realistic date at this time.
based on the training requirements and how you're going to phase and integrate that in, have you already been, or there's a plans to work with a Vantage system, so that when someone checks in to a heliport, the ground crew know who's been through the training on the new rebreather, and they can position them accordingly into the...
Absolutely, and the Peter will be helping us with that. Vantage, there will be some changes, I'm guessing, made to the Vantage system to flag what training you have had.
Yeah, absolutely.
Do you want to, Mark, do you want to speak to that?
We're actually meeting with Vantage next week to discuss that. But we're working on a plug-in to the standard, if you like, to take care of this Cat A. So it's all working pretty much aligned and pretty much joined up with the work that Colin's group's carrying out. So Peter was going to support that.
There is a lot. I'm actually very impressed coming from inside the workings of an organisation that I'm pretty familiar with, coming out to work for a body that has connections. We have stakeholders, as we said, from medical, from the training organisations, from a PETO, EASA, the CA. I'm incredibly impressed how everyone has worked extremely hard to come together on this. And I think you'll agree there's some pretty impressive timelines there. So having told you we're not putting our own group internally under any time constraints, I think the output is incredibly impressive, and I mustn't overlook, neither should you, the amazing work that Survitec have done. They're the OEMs, these guys, they're the development and design teams. They've pulled this together, and actually as a group we're standing on their shoulders on this one. They've done an amazing amount of work. Are there any more questions?
Yeah, what's the duration of the air bottle and why is it so big?
What? Very good question. So if those you didn't hear, what's the duration of the bottle and why is it so big? It's so big to give you the best possible duration that we can. There are other systems out there with smaller bottles. Currently, I believe this is carbon steel, mild steel, which is a standard, a compressed air bottle. We did look at actually sort of a graphite type system, a composite bottle that is lightweight, but it's not commercially available. So you may well see, and in fact this entire system is actually part of our normal activity of continuing improvement. If you think back about the iteration of survival suits, life jackets, we had nothing, then we had LAP, then we had the hybrid rebreather. This is what you're looking at is actually the next generation. And you might find that after this, in some short time scale, you might find some subtle changes being incorporated into the system, and that may include the lightweight bottle. To answer the other part of the question, the duration is quite complex, and what I'll probably do is I'll introduce you to Dr. Coleshaw, because I'm sure you'll have more in-depth questions. But generally speaking, it depends on your breathing rate, of course. There's a fixed amount of air, depends on your panic breathing rate, your age, your fitness, the water temperature, and the water depth at deployment. So it's a model mixture of all those things. But there is an envelope, there is a window of expectation. We have a minimum standard that we will exceed, and we have seen the system breathe down to 4 or 5 minutes in very benign conditions, warm water, people are very calm, and bearing in mind in anger, the adrenaline will be flowing. But we aim to exceed the standard, and that standard is predicated on the time you are expected or people can escape from a crashed helicopter. It will well exceed that standard. If you want any more details, probably what we'll do is we'll speak to Dr. Coleshaw, and she can give you much more in-depth information about that. Do you need to add anything to that, Sue?
No, I don't think so. I mean, I think in terms of the size of the bottle, it is a balancing act. If you have a smaller bottle that's less cumbersome, you just don't get the performance from it that you get with a bigger bottle. So that's a balancing act between a little bit of discomfort when you're flying, but gives you a much better chance.
Yeah, but it just makes the life jacket more heavier, doesn't it?
Yeah.
You want it to be lighter, don't you?
But I say, do you want to be comfortable when you're flying, or do you want something that's going to
I'm comfortable
actually
where I fly now.
if you're the unlucky person that has to use it in anger?
So comfort versus safety, actually, it's a question I had the privilege to work on the EC225 group when we had that issue before, and when we were discussing helicopter types, there's a perception of safety at times, which is actually the line is blurred between that and comfort. And it's the same here, comfort and safety. We have to be quite hard-nosed and focused on what we're delivering as a team. And we want to give you the most duration that we can with the best equipment that we can. And if there's some discomfort, well, some things we have to put up with if you want the best that's available. And it's a trade-off.
Now, putting 19 guys or people in here, a helicopter in the post use with 19 pressurised bottles. We thought about the possibility of one of these failing in transit and what the consequences are within the post use of the helicopter.
I'm going to defer to Greg about the bottle, because I think there's two different parts to that question. Quite understandably, the helicopter seating, as a question we've heard before in other forums, and the staggered seating and access to windows and so on. That's one question, but I think the question about bottles failing, not only are we meeting civil aviation standards and the EASA approvals with all this equipment, the bottles meet all the old-fashioned, the BSI and the new European norm standards as well. Greg, do you, the testing for the bottles? You know, okay.
I mean, it's, sorry,
Well, I was going to add, it does meet standards that have been written for scuba diving equipment. It also meets military requirements, so they did things like dropping them from great heights and did a lot of sort of robust mechanical testing on the system. So I think it's as safe as it can be from that point of view.
It's a very good question.
If it does go off, the bottle comes through, what it could do inside the helicopter.
Absolutely, versus having this in an incident, nothing is without risk, but on a balance of probability and risk, I personally would much rather fly. I'd much rather my son flights with this. I have a son who's done his bows yet and he works offshore. Yeah. No, it's a fair question. I'm pleased. I'm not trying to decry it. It's a really good question, but the standard's been rigorous. And it's probably worth reiterating, actually, at this stage, is that we didn't go back to first principles. These are not concept devices. We haven't just rushed something through from the drawing board. These are all based on tried and tested designs, and this system, you'll hear it described as PSTAS. It's not PSTAS in this setup. PSTAS system is actually the bottle and the demand valve, and it's based on the system currently in use with military passengers. Okay, so we've built on other R&D that's gone and certification that's gone out there, which is why we're able to be in the position we are now, which is a phenomenal timeline when you would normally expect this to take manner of years rather than months.
With the bottle mounted on the rib cage, has there been any consideration of potential damage during heavy impact onto your rib cage that would then impair your ability to breathe?
In the testing that we're currently doing, impact is not a consideration, but I'd have to defer to Sue, because in the development of the standard, I'm guessing there's been some consideration to how these systems are mounted and used, and other unintended consequence. Was there anything that you did?
Well, not that I've done. I'd have to check back if there's been anything done in terms of humans impact. So there's certainly been impact failures on the bottle.
So the bottle is well secured, though, so the bottle wouldn't become a loose object as a missile. And presumably your thing is if you're forced, it'll squash you between whatever immovable object and your ribcage.
Potentially you could have your bottle mounted in your seat in front of you and take it that way.
You probably wouldn't meet the deployment times. You'd be surprised underwater if you can't see, if you miss that. This is all about deployment underwater with no notice. That's why it's bright yellow, and that's why it's there. You can't miss that. The other thing as well, and I don't really want to digress too much, but while you've made the point, other systems that we considered have, and I think possibly it's the one you're alluding to, there is a system which has a bottle and a mouthpiece integrated into it, which is mounted in a pocket. You pick it up, you put it in your teeth. It looks simple, and actually we considered that. We wondered if that would have been a faster route to our workforce. And actually there was something staring us in the face. You hold this bottle between your teeth, and actually in water, weight's not the consideration. The consideration is if you dislodge that, getting out, other people thrashing about trying to get out of a helicopter, your emergency air is on the bottom of the helicopter. You don't want to be on your hands and knees or trying to swim down for that. There's a great recovery option for this. The nose clip actually holds it securely on your face, and the bite piece is very good. If you lose that, you're back to your jacket, you run your hand down the hose, and it's straight back in your mouth. You've not lost the bottle. So I think I've answered. Are there any more questions so far?
Is that bottle live then?
You mean in use?
On-demand
Live, on-demand system, yes.
So it's live?
Absolutely.
Right, so your jacket, or you put on your thing, you can turn the wheel?
No, you can't. No, this is a prototype, so there's already design changes that we're looking at the moment. In fact, late as last night with Greg's team, we sat down and we started finessing this design. We have to be careful that we have to have a design that is actually fit for purpose, but it's easy to go over the score and start making little design tweaks. And like I said earlier, you're very likely to see another iteration of this sometime in the future as well, and especially once we get feedback. So we're doing fairly scientific trials with a small group of people to satisfy the requirement. But once we start rolling this out with our colleagues with the P2 and our training providers, and we get mass feedback, and we are also hoping to do trials with a small representative user group, that's when we'll get the real interesting data back, and we'll get comments like that, which will be very useful to feed into the design.
There's an EBS system only fitting on the right side.
That was a consideration. I don't have the answer to that, but we did ask the question about is there any ergonomic part of the design which says left-handed people should have it one way and right-handed another? And I think, and again, I'm looking over to this side of the room for help on that.
The system can be fitted on either side, but you have to make a decision that it's fitted on one side for everybody, because we operate a pool. So those life jackets get transferred offshore on the incoming passengers. So it's like the same reason why we have a standard size and not size life jackets. You've got to fit every individual, take everybody into consideration. Yeah. That's why the system is designed to be deployed with either hand.
For left and right.
I think it's to make it intuitive. It's there, it's in the same place, so you can deploy it. The benefit is it's deployable with both hands, one hand.
That is part of the requirement of the standard, that you can deploy it within the timescale, whichever hand you're using. And the consideration was that will depend on which side you are, where you're locating your exit. If you've got one hand that's been injured, you can still deploy it with the other.
Any more questions?
I'd like to think that during your survival, that as a minimum, an individual would be given the opportunity to use the life jacket and a working bottle, should he choose to do so, or preferably everyone would get a chance to train with these with working examples. Is that the plan?
Yep. So the training needs analysis, which is underway at the moment, is looking at that. What do we need to do to get people to confidently and safely deploy these in an emergency? What training do we need to do to give people the best training we can further down in more complex training? And we as a group haven't had that decision because we're waiting for input from the specialists on that. But that training is likely to run from the options that are in the mix are, you start with a very minimum, which is a video, and then you move to dry training where you'll touch it, you'll feel it, you'll breathe with it in air. We'll get people in the water, or we'll put their faces in the water so they can breathe, they get confidence, understand how you achieve a lip seal, and so on, and then you run right up to the Hewitt. Where that line stops, what is reasonable and what is acceptable as a standard will be decided, will be fed into us by the external group. But certainly there is absolutely, let me make this clear, absolutely no thought that this would be rushed into service without the appropriate level of training. Absolutely not.
What I'm thinking is, in order to be able to use these at Park New Tech or Spy Tech, they're going to have to recharge bottles if we're going to be allowed to use them. With the rebreather, you rebreathe into the bag, but you never ever had the opportunity to use the canister.
Yep, absolutely.
Get the opportunity to use it in the bottle.
Yeah. I am pretty confident, I need to have that confidence, that would be part of the training. Because this system, you don't have an alternative where you can do what is described. The question was, for those of you who can't hear me, was about the fidelity of the training and whether you be actually allowed to use this for real in the pool, because at the moment we have a hybrid system and we don't test the compressed air element. And it's a very good question. So we do a part task trainer at the moment, so you do the counter-lung element, but you're not trained with the compressed air system. What I can tell you is, because this is an all or nothing system, if the training requirement says that there is in-water training required to carry this offshore, then you will use the system with a live bottle. Okay? I think it's probably getting a bit difficult to hear, unless there's any final questions. The team are available for questions after if you want to come across and have a one-to-one. Thank you very much.